Continuing with section 5.2, using perpendicular bisectors, we have example 2. In the diagram, JM is the perpendicular bisector of HK. We have two questions. The first question is, which lengths in the diagram are equal? Well, obviously, we have segment LK congruent to segment LH. The lengths are given. We also have two triangles formed over here with this right angle. If one right angle is congruent at an intersection, then we have all four are right angles. So if that's the case, we can get these two triangles congruent. We have, if this JM is a perpendicular bisector, then it's a bisector of HK, and HM is congruent to MK. Also, we have line segment MJ congruent to itself by reflexive, so we have triangles HMJ congruent to triangle MJK, which makes corresponding parts, these sides of the triangle, also congruent. The second part is L on line JM? Well, at first it doesn't even look like line L is long enough to go through, but we have to remember that a line goes on forever in both directions. It has to go through point L because 12.5 line segment is congruent to 12-point line segment. They're equal distances to the end points of the perpendicular bisector, so it has to go through that intersection. Our last example has to do with three forest ranger stations that are the same distance from the main office. Describe how to find the location. Well, let's look at this drawing. We have three forest stations. My pen narrower. And they are equal distance to the main office. Well, we want a main office somewhere in this middle of the three forest rangers, and we can describe how to find that location of the office. We will make it a triangle, and we can use perpendicular bisectors to find the middle of the triangle. We have a blue perpendicular bisector. We have a red perpendicular bisector from the second side. And we'll have a green perpendicular bisector from the third side. If the green perpendicular bisector is equal distance to station 1 and 2, and the red perpendicular bisector, every point on it is equal distance from station 2 and 3, then the blue perpendicular bisector is also equal distance from stations 1 and 3. This point of concurrency is equal distance to all three of the forest stations. There is no problem number 1 to fill in on the form.